September 28th at the same time, 2 to 4 o'clock in the afternoon to cover whatever we could not finish. So you don't have to register for that session. We will email everybody on the registration list. If you plan to attend in person, we will still be in this room, lab 16 at the same time.
But on a Wednesday.
But on Wednesday, yes.
Yep.
And also we will take a 5-minute break at around 3 o'clock. Get the report.
That's already.
Okay. So last week, at the very end of the workshop, I tried to finish indexing and subsetting of data frame, but did not. So I will quickly review what we talked about and move forward from there. So last time we kind of talked about the vector, especially atomic vector, which is the basic data structure in R. And in R, it has 6 types of vectors. We kind of talk about.
I can't see the PowerPoint, sorry.
Oh, I
need
forgot
to share.
Yeah.
Sorry.
You need to.
Oh, yeah, I will. Sorry about that. There you go.
So there are basically 6 types of vectors, and double, which means numeric, and character, integer, and logical. And the other 2, complex and val, we did not cover. And also we use some functions to inspect vectors. We use the length function to check the size, how many elements in a vector. And also we use structure. We did not talk about type of. And we use structure to see a brief summary of the vector. We can see the vector type and how many elements, and also we see some examples of the elements. And next we talk about the index and subset of vector. We use the symbol square bracket, and we talk about 2 methods. One is to use the integer to index a vector, and another one is we use logical vector to subset or index a vector. Then we talk about missing data. In R, R uses NA for missing data. When we do some calculation, if we have missing data, it always returns NA. So we can add an optional argument, NA.rm, to ignore the missing data. I mean, NA.rm equals true. And also we talk about using functions to handle the missing data. The most commonly used one is .na. We can use that to check if an element is missing data or not. And also we use that to calculate how many elements in a vector is missing. Then we talk about data frame. We kind of we use the read_CSV function to read the survey data into R, and we talk about some functions to inspect the data frame. We use the DIM dimensional data structure. So it has the row number and the column number. And also we use view, the function view, to see how the data looks like. And we can also use function head and tail to see part of the data. We also use the function str structure to see a brief summary. And another function is summary. That is for the statistical summary of the data frame. And then we start to talk about the indexing and subsetting. We mentioned we can use 3 different symbols to subset data frame: square bracket and double square bracket, and the dollar sign. Now we can open the file we used last time. You must have received the zip file here on my desktop. You can download that to your computer and right click and unzip it. And you can put it in the download file or put it on your desktop. And when you open the Sarfi folder, and you will see the Sarfi RPROJ file, and double click to open this file. Anytime you open an R project, always click this R project file.
And remember, if you're using the computers here in the room, you have to reload Tidyverse. So if you need me to help you install that from the packages, let me know. So
First, make sure you have Tidyverse installed. If you're using the computer here, you have to install it again. And to install, you can go to package and then click install, and then put Tidyverse here. Make sure install dependencies is checked, and then click install. It may take a couple minutes to get it installed. Back to our file. This time we're not going to create a new file. We're going to use the file we worked on last time. So click the folder scripts. And we have section 2 data in R.R file. And double click, it will open here.
So
just wait for a second and then I'll help. Those of you that are using your own computers can open your file that you have from last time. Yeah, so you don't have to use those.
So for those packages, you install them once, you can always use them. But every time you use them, you need to load them. So that's another step.
We're good?
So if you open this file, S2_data in R, and as I mentioned, every time when we use the package we installed, we load it to the environment. So I think we have the sentence is already here. It's on 98 line, on this line, and you can run this file. Just Control Enter, it will run. It will load Tidyverse into our current environment. since we are still going to use the data Sarfi, we will read the Sarfi file. We already have this command line here, 102, the line 102. So you can just control enter to run this line. And so first we will bring talking about using square brackets. We already see some examples this time. And let's say if you want to see the first element of the sixth column, you can just use interviews. That's the data frame, and then followed with the square brackets. One, that's the row, and followed 6, that's the column. When you run this command, you will see the result. First, it tells you it is a table, it is a data frame, it's a 1-by-1 data frame. Even it has only one element there. That's the first row or the first observation of the column respondent word type. And the data type is character. If we want to see multiple elements, let's say we can see the first through the third element of the column, let's say 7. We run, we got 3, 1. That's the rooms. The first 3 rows of the rooms column. And it's also a table, it's a data frame, it's a 3-by-1 data frame. This colon operator is kind of, it will create a series of numbers in sequence. So it can be increasing. Let's say it's not necessary to start from 1. So if you input 2 to 4, it's 2 colon 4, it will create a 3-element vector. And also it can be decreasing.
Oh, sorry for it. So I just want to know why we're doing it. Like, what is the end goal of our data? I'm doing this, but I can come back with the objective of.
So the question is, why do we want to do the subsetting? Sometimes we were not going to use the whole data set. We may use part of the data sets. So we can use subsetting. We can subset based on what we really need.
Sorry, and just to be clear, this is pulling from that Safi Excel sheet, right?
Okay. So again, we can take a look at opens here. So when you view, use this function, and it opens another tab, and you can always see this is the data we're currently using. The same data as we used last time.
Whenever we say 19.3, it's pulling from row 19, column 3, and that's all the information on there.
Oh, this one?
Yeah.
You mean this one? Oh, no, this is, I'm giving an example for colon. So colon is, it will create a series of numbers in sequence. So let's say, so the sequence can be increasing and also can be decreasing. So if I kind of, this is kind of reverse, this is 2 to 4, it will generate a vector of 3 elements. It starts from 2 and 2, 3 and 4.
Oh, okay, thank you.
This is kind of explained here. Another way to do that is so we will see the same results. Instead of doing that, type all those elements, I can just use colon. It will generate the same vector. So, okay, we can also kind of subset of the one row or one observation. Let's say interviews, and this is the third observation, the third row, and we leave the column blank. That will we will kind of means I'll take the whole row. So here we have this is a table is 1 by 14 data frame. So we have all the from all the variables, the information from all the variables, but only the third observation, only the third row.
The third entry in the table.
Yeah, the third entry. And if we want to select only one column, we can do the same thing. Interviews and leave the row index number blank, and then we can put the column number here. So 6, that will be the whole column of respondent ward type. So this is a table 131 by 1.
So now we're looking at a column in there. I keep repeating a little bit because I think we have one person that kind of is not understanding Tibble. And so I was hoping that these two exercises would help marry that in people's brains, that we can look across or down the Tibble.
Tibble is kind of one, is a lazy type of data frame. All tables are data frames, but not all data frames are tables.
So why we're not doing metrics, like why we are not trying to see the rows and columns together? Why just vector?
Let's say sometimes if you want to do something with one column with this only this variable, so this is the way kind of you extract the column information, the variable from your data set.
This is a very specific case when I'm not analyzing the entire data set. I'm just want to have a portion of data set in one variable. That's where we do all these things.
Yeah. And also for if you want a specific column, you don't have to use the colon. I mean the comma. So you don't have to put the comma at the beginning, and this is the same. I mean, this too, you will see the same result. If you want a specific column, you don't have to have the comma at the beginning.
And I think some of the reason why we chose to do it this way is that we're trying to be the most generic for the most data sets that we could see. And that government data sets sometimes will have information that you don't need, and then you will have information you do need in other spots. So that's why it may not be the best for every data set, but
Big data like you research. And
Actually, for this
Yeah.
Starfleet data set,
okay.
they have more questions than we have only 14 variables. But the survey, they have more questions, they have more than 14 questions. But for this workshop, we pick only 14 variables. So it's this is subset of the large data set.
so it's more important when we do secondary analysis, because when we do primary research, we just have small, but when we do secondary analysis of other person analysis, then we take small chunk and a different study.
Yeah, no, I get that. And so I think we're really trying to get people all on the same page to do that first jump, not the big jump.
Yeah, that's
But
amazing.
that's gonna apply to you for sure, right? Yeah.
So also next we're going to talk about the minus. We can use minus to exclude rows or columns as we did for the vector. So let's say interviews still were accepted, and we know we have 131 and 131 record. We will use minus to exclude the rows from the 7th row and 7th to the 131 rows. And when we run that, we will see the first 6 rows of this data set. That's kind of equivalent to the function head. And also we can use minus to exclude rows, columns. One, so we will kind of remove PID from the data sets. So the new data set will have only 13 columns. Those are examples we use the numbers of rows, the numbers of columns to do the subsetting, to do the indexing. We can also use the column names. Let's say interviews. We have the column village, and we will see this column. So the square brackets, we use that for indexing or subsetting purpose. We will always get a table or a data frame. And the indexing starts from 1 for both rows and columns. Another symbol we're going to talk about is double square bracket. So we can see the same example, let's say 1, 6. That's the one without any. And it looks like we get the same result, not doubt. So that's the single square bracket. And this is the double square bracket. And what's the difference? So you can see the results. The double brackets returns like this. The single brackets returns like this. Single brackets, it returns a tibble. It's a 1x1 tibble. Double brackets, it returns a vector with one element. The same, we can put the column name. Instead of kind of one column, it's kind of long column like this. It brings out all those elements. It is a vector of 131 elements. If you want to check if it is a vector, you can use the function is vector. And then you put this here. And we'll run that. It will show you true. Say we keep those square brackets and we run that, it will tell us false. It is a tibble. It is a data frame. It is not a vector.
So this is showing the difference of how the RStudio is reading that information.
So the single brackets, single square brackets and the double square brackets. Some functions, let's say some argument, it requires a vector, some requires a data frame. So we have to kind of understand their data structure to use them correctly. And next, we're going to talk about the last symbol, that's dollar sign. So we can use dollar sign to call the variables, the columns, say village. This time we did not put village into quotes. With the dollar sign, we don't need to put them in the quotes. And then we get the results. It is also a vector. It is not a tibble. So a quick summary is when we use the single square brackets to subset or index a data frame or a tibble, we will get a tibble. But when we use the double square brackets or we use the dollar sign, we will get vector.
Is the dollar sign and the double bracket equivalent?
Yes, you can say it that way. But you have to put, if you use the double brackets, square brackets, you have to put
The quotation mark?
yeah, in the quotes.
Sorry for asking again, but like, why double bracket village is a vector and why single bracket village is not a vector?
That's how it is defined in R.
That's how R is reading it. So it's asking it from different views. So as we look back through there, you can see that it's going to bring back the text or the vector, if you will, of that item, or it's going to bring back the what's in the up just a bit, changing so they can see the is ones from both of those. In the console. So right here,
Here.
oh
we
yeah, that's a good
use
one to
the
show.
Single square brackets, and you will see it is a typo, and that's the result. This is how R is defined. R define a single square brackets, it will brings the results as a typo, and the double square brackets, it will bring a vector. It is defined.
Did that answer your question?
Yeah.
Okay,
Instead of just language,
yes,
we can say I am a student, but I cannot say I is a student. That will be wrong. That's just how it is defined.
that's a good example, Jean. Yes.
Just new language with new different grammars. and stuff.
That's right.
Okay, so next we're going to talk about a special vector. It is called factor. So we will create a new section. We use Control Shift R. It will bring this intersection label and then factors. That will be the type. So factor is a special vector in R. We use that to handle categorical data when doing statistical analysis or when we create plots, create a graph. Categorical data can be numerical and also can be character vectors. Here are two major differences between factors and the normal vectors, the regular vectors. We know we use factors to represent the categorical data, but it's in the factor, it stores as integers. So factor, it may look like or behave like a categorical vector, but it actually treated as integer vector in R. This is the first difference. The second difference is once created, factors contains only predefined values. We call those values levels. So by default, R will sort these levels alphabetically. So to create a factor, we are going to use the function factor. So this time, let's say, we will define a factor is called respondent floor type. Alt minus this assignment operator. And then here we have 4 elements, but 2 levels. First, and
Remember a shortcut for that little larger than minus?
that's alt minus.
Yeah, I got it all minus equal, right?
Alt minus.
Okay.
So we can use functions to inspect the factor. So the function we can use is levels, and then respondent floor type. And enter, we will see it has 2 levels. The first one is cement, and the second one is earth. Even in our factor, the first one is earth. The levels it will ordered or sorted alphabetically. So cement is the first level, and earth is second level.
What? What we're
Oh, we're entering that information for the respondent floor type.
Function we can use to inspect this factor is n levels. Respondent floor type, we will see two. We have two levels. You can also just type in respondent floor type, and it will list all the elements, and also it will show you levels, cement and earth. In R's memory, the factor is stored as integers. So cement is 1 and earth is 2. We can tell that we can use the function as numeric, as dot numeric, and we can put respondent floor type here. And then we will see the number. We cannot use as dot numeric for just a regular vector. Let's say for this is the vector, this is not the factor, just a regular vector. If we use as numeric and we paste this vector here, and when we run this command, we will get a warning message and it will change everything to NA. So when we have a large amount of data with kind of limited unique values, a benefit of using factor is it will save space, save the memory space. It will save all those elements as numbers instead of those strings. This is kind of the first difference. The R will treat factors as numbers, as integers. And the second difference is factors can only contain predefined values or levels. When we add a new value beyond those current levels, we will see some warning message. Let's say respondent floor type, and we know currently the third element is cement. We want to change it to brick. When we run that, we will see a warning message, and it says invalid factor level NA generated. We can take a look at so we still have two levels, cement and earth. instead of cement as the third element, currently is Na. Because it could not recognize break as a level. If we do want to add a new level, we can use the levels function. We just use the levels function to check the levels of a vector. We can also use levels function to add a new level. So we will assign this new vector to the levels. Again, when we run this row, and we check the current value of this flow type, we will see break is here. And also the levels, we have cement, earth, and breaks is added. It is added to the end. As we added it to the end, so it won't kind of bring breaks to the very beginning, even it starts with B. Understand what's the difference between the vector and the irregular vector? And why do we want to use vector to manage the categorical data? We just saw it can save memory space, as it kind of saves the vector as integers. And we can see some, we will see some other examples to show why we want to use the vector to represent categorical data. So the first example is we can reorder the categorical data as we want. First, we will define a new vector. This is a vector. This is just a regular vector. Medium. We sort R1, the vector. We will see it sorted alphabetically from H, L to M. That's not the order we want. We want it sorted as low, medium, and high. If we convert to vector, it will be easier to handle that way. Okay, so first we're going to find ranking level. We want it to low. And we will convert R1 vector. Name is R1 vector. And use the function vector. is R1 and levels, well, take a look at vector. We will see is medium, medium, and then we will see the levels, low, medium, and high. And when we sort R1 vector, the result of this sort is low, medium, and high. So we can use factor to easily reorder the categorical data the way we want. Other examples can be from January to December, or from Sunday to Saturday. And some, let's say, some maybe some opinion options, disagree, strongly disagree, and we can order it the way we want.
So if there is anything we don't like, we need to reorder, like if it's like high, medium, low, and we want like low, medium, so we can do that.
Yes.
Got it.
You can define the order the way you want. That will identify it. So this time we're going to define another R2 and medium. This spell the second medium and also we lowercase the last. So words instead of 1 we replace 2. So when we check this result of R2 vector, we will see 2 missing data because of the typo. This one we misspell it A, and this one we lowercase l. And also you can use another function class vector and put R2 here. So it will show you exactly where the problem is and how it was spelled. The vector can help us to identify type. Data. Also, factor can improve data visualization. That will be the third example. So this time we're going to use the data, the column member. If the member is associated with, if they are with an association. So with an irrigation association. Association. Okay. So this is the data we're going to use, member association. So we can see the result NA, missing data, or yes or no. We have 3 different answers. So we can assign that. There was. Convert it to so now this is a factor, not a regular factor. And when we plot it, we will see a bar chart. One column is no, and another bar is yes. The problem is we have missing data. It did not display missing data. When we check the member association, it shows the levels no and yes. To add missing data back, and use the function add NA. Then we check it again. So it has NA back. When we plot it, we did see a new bar displayed, but it doesn't have any label here. So we can use the levels function we can assign it and determine, then we plot it again. So we use the factor to make the label clear or to display the missing data, to improve the results, the visualization. So for the function levels, we use the function to check the levels of factor at the beginning. And also we use levels to add a new level. Yes.
Can you go to the code again?
To the end. So this time we use the function levels to rename a level. We use the function levels in 3 different ways.
Getting any plot.
I will quickly talk about the convergence. Sometimes we can use factor to convert a vector, regular vector, to a factor. And also, sometimes we don't want to treat it as a factor. We want it to come back to the regular vector. We can use the function as character to convert a factor. It will get back to the regular. Sometimes if the factor is numbers, we may have some problems. Let's say so this is a factor, but all the elements are kind of numbers. And if we want to change it to so you see it is a factor and it has 4 levels. If we want to change it to numbers, we may use numeric. It becomes to the levels. Instead of those numbers, those years. So we can first convert to character. And then we convert to numeric. So we kind of nest this two. First, we convert this factor to character vector, and then we convert them to numbers. So it is 3 o'clock. We take a 5-minute break. If you have any questions.
So his question, he can keep both lots open, but then when I looked at it, he just reran it and it worked. So I don't know why, but then it come up, I didn't do anything, he just like ran it again and it worked. At first I thought, especially because it was plotting the member association, I thought, oh, he's misspelled member association someplace, but it was right. It was on the last exam. So, yeah. So Monica, your friends didn't want to come with you this time.
All of them are actually in the official R class.
Oh, gotcha.
I got bumped to TA, so
Oh, I see.
this is me trying to catch up.
Catch
with
up. Gotcha. I don't know if we're as good as the real class.
So far, it's been pretty, I've helped them at least on 2 homework assignments. So
Oh, hey, good. Glad to hear that.
I'm like, that looks familiar. I've seen that. Biological sciences, biology.
So that will be our class. It's not our class for something else.
It's just R.
Just our.
Just R.
That was why I was like, I don't know if we can't be that level. But she thinks maybe.
Be somewhat up to them. It will be good when I take the class next semester.
Okay, sounds good.
So the class will use R for statistics.
Yes. Which, are you guys doing any more R classes, or is, I know there's like the session 4, but anything else after that?
They're kind of working on using R for text finding.
Ooh,
Yeah, working on that, but not ready yet.
Yeah, maybe next semester.
I'm ready for it.
Or maybe
Ready for it.
next summer.
Takes a while to develop, I'm sure.
There is a very good book for using R for statistics biology.
Well, everybody for that R class is using that very first book you have.
Or for data science.
Yeah.
Yeah, I think this one is for the statistics for biology.
Excellent. I have this bookmark, so look, you can grab that
Okay.
one. Thank you.
Pretty good book, R for data science.
Yeah.
And Hadley, he's the person kind of one of the developers of this package for tidy.
Wow. Okay.
Yeah, that text, I really like it because even if you don't know anything, it makes it simple enough that you can understand it. So sometimes I think when you start reading, especially programming and language books, then they're like, we assume you know all this and then start, and you're like, oh, but that one I felt like brought me together too.
Easy R. I think it's easy R. I did not have it. We don't have in our library. So I think
I'll add that to my notes. And Elizabeth Gomert.
where they may use some examples from political science. So not from biology, but that one is from biology.
Water statistics.
Susan Thomas. And I think she's from. Oh, it's already 3:06. Next, we're going to talk about dates. So date and time information are quite common in research data, and a good practice for handling dates and time information is to store each component as a separate variable. For the components, I mean date and month is a component, year is a component. And so, let's say, although the reason why we want to do that is first, it's, there's some regional differences, and so we can specify the time zone in another document. And different software may handle dates and time difference, right? And also sometimes we may have incomplete date and time information. We may have only have dates and months, and sometimes we only have months and the year. So this way we store them separately. That will give us the flexibility. So in our data, we have the date of the interview date. Interview. Yeah, we have interview dates. So that's our interview date. If we want to check the data type, so this means the date and the time associated with the time zone. Out of PONSI. And to handle to separate each element, each component from a date time data, the package we're going to use is called rubric date. Rubric date. It is a package under the big umbrella of Tidyverse. But when we load Tidyverse, rubric date is not loaded. So if we want to use it, we need to use the function library to load rubric date. The function we are going to use for kind of extract date, month, and year information, we will use the function day, month, and year. That's three functions in rubric date. So to make our life clear, we can kind of just name it as dates. Here, when we run this command line, we create a new. We will use that. The function we'll use is main. And so see here, we extract only date. And we can assign it to interviews. We will call that day. we will assign this vector to a new column in interviews. When we run this and when we open that, we will see the new column is added to the end.
Sorry, it's not forming.
Okay. Back to the command. We use this command to add a new column to interviews. So now the data frame interviews has 15 columns. The data we get is from the dates, and we use the function day to extract only the date information. We can do the same for month. The function, this time the function we use is called months. And the new column name is also, we name it month. And we can do the same for year. When we check interviews, we see we have 17 columns. So the last 3 columns added is day, month, and year. You can name them whatever you want, but the function you have to use is day, month, and year. It's not necessary you name them day, month, and year. In R, when we read data into R, sometimes the date and time information are read in as date and time value, but sometimes they read in as characters. So we need to convert characters into date and time. We can see and example character dates. We create vector. Let's say if we kind of read in some date and time date information as characters. So we check the structure of character dates. We can see this is not date and time information, this is character. We want to convert it into date. The function we are going to use is as date. This function also comes from the loop rate. So you can see free date. It's also comes from free date. This factor here and then we will define the format. We will. So currently we know our data is month, date, and year. So that will be M percentage M slash, which is copy slash, and date slash Y is the capitalized Y. As here, year is in 4 digits, we use capitalized Y. So we can see the results is convert to the date information. Okay, we want to check the data type. We're going to use structure. And we can see instead of character, now it is date. Again,
Does it work for you that time?
It's working out, but like, why do you do that, Mike?
okay. So, a good practice for handling the date time information is to store them separately as each component. And the function we use is day, month, and year. This day, month, and year, we can only use them when you have the dates, the format, the data format is dates. But sometimes when you read in the data into R, the date is stored as characters instead of dates. So you have to convert the characters into dates. Then you can use day, month, and year to separate them. So this is kind of why we talk about how to convert character dates into date format. So this format, this how do I say that? This characters or these letters is very important. If use, I mentioned capitalized Y is for 4 digits. If you use lowercase y, that will be for that is used for 2-digit years. So it will cut the first 2. So this year becomes 2020 instead of 2012, and this is 2020. It's also 2020, and this one is 2021. How can I remember that? You can always check. Use the help document. So we'll see the format here. And it defines all the letters. So I think we have D for date, and we have M for months. If we use the uppercase months, that is minutes, it's not real, it's not months. And also we just talk about why. This is 2-digit year, and this is 4-digit year. And another function you can use is, title is not one function, it's just three functions. You can use convert characters into date format is, MBY and EMY and YM. Those are the three functions, group of functions. For our case, we have months, day, and year. So we're going to use the function MDY. So you can just use MDY dates and it will convert directly. Even you make changes like here you different it still can convert correct. So this kind of more flexible. Okay, this is the dates in R. Any questions? We're going to save this file and close it. And then we're going to talk about data wrangling. So we will create a new R script. And we can save it in the scripts folder as S3. Then we will add kind of information about this file. Like data wrangling. Put those two lines out. So shift.
How do I name that new project? How did you get that S3 underscore data underscore wrangling?
You can save it.
We can save it. I just create a new script file and then I save it. And I save it here.
Oh, okay. I think if you clean the console, that would be like,
Okay, so we can clean the console. Actually, before I clean the, okay, wait. So clean the console, you can use this broom. You can clean the console. Oh, I think if I remember correctly, I'm not 100% sure if this is the function. Okay, it's not. This.
yes.
So first, we need to bring, even we're in current environment, we already have the tidyverse loaded, but as we start a new file, I still want to bring the tidyverse. So kind of anytime you open this file, you will still have the package loaded. And also we want the interviews file back. So the data is interview, and then we use the function CSV, and the data will enter data folder and underscore bin CSV, and also specify NA. So next we are going to talk about package is called dplyr. You can see from here. So, anyway, it will show the dplyr is loaded to the system. We were going to use dplyr to wrangle the tabular data. We will, how do I say that, subset data and add new column or do some summary statistics. We just talked about using square brackets to subset data frame. We can also use functions to do that. Let's say the function select. We can use the function select to choose the columns. We can also use filter, the function filter, to for conditional subsetting. Kind of select the specific rows. The function select has basically the first argument is the data frame we're going to use. And then it follows with the column names we want to pick. So the data set is interview. And the columns we can pick, let's say, village. And we don't need to put them in the code. The number of family members. So now we see 3 columns we pick from the data frame interviews. We can also use the colon operator to pick some columns. So now we. So here we get 12 columns from village till month's lack of food. We can also use minus to remove column. Now this columns. Village, which is supposed to be here. Use the function filter.
That's right.
Sorry. What we are doing it again? Can you give us an idea on that primary? What's that?
So, as I said before, this is a different way to subset a data set. So sometimes we just want to use part of the data set. So we can use square brackets to do that. And also we can use functions. So to pick or to choose a column, we can use the function select. To choose the rows, the observations, we can use filter. So filter, let's say we can have some conditions. Let's say the village, we know we have 3 different villages. We can choose one, this kind of sage village. So currently we see we got a new, the results have only 39 records, but it has all those variables, all those columns, 14 columns, but only 39 rows, which the village is this sage village. The filter function also allows multiple conditions. Say, greater than and number of hills. So we get even smaller data sets. We have only 10 observations. Those respondents came from the same village and their rooms are greater than 1 and their family rooms and the everyday number of meals is greater than 2. Comma here kind of equals the same as and. So it needs to meet all those 3 conditions. Instead of comma, we can use and. We get the same result. We can also use the OR logic. This type symbol. We have an image. And this time we got 82 results. So this respondent either came from this Sage village or from this God village. We use this pipe symbol for the logic OR.
Question. Why is, so hashtag means you're making a comment, why is that like a light blue? Isn't it normally green? Am I just colorblind right now? Never mind.
No, it
That's-
was different colors.
Yeah, it's different color. The green is for something we put in the quotes, and it's green. And
So it's just like showing it's different.
yeah,
Okay.
But you're right, it was green before, so it's just one more color.
it's green. Yeah.
Gigi, do you know how to write the pipe in Mac? We don't know how to write that on.
I think that it's the same.
But I think it's at a different location. So it's usually on the backslash.
It's combination Alt 7.
Alt 7. Thank you, Monica.
This is Google. Thank you, Google.
Yeah, thanks, Google.
And also select the rows. So we can put them together. Let's say there's 3 ways to do that. The first is, say, first we want to filter village equals to this Sage village. And we will want to assign that to interviews 2. And then next, we want to interviews 2. We want to select only certain columns. Select the column from village through respondent or type. Interviews 3. We will run this both, and then we want to check. Interview 3. So it opens this. Interview 3. If you want to run some command, you just run in the console. You can use the upper arrow, bring it back. Then
That's the code space.
excuse me.
She wants to see the script. Yeah, because you went so fast. Right.
Oh, okay. I just filter the interview and assign it to interview 2 and select only certain columns from the interviews 2 and assign it to interview 3. 3. And then you can view interviews 3. That's what I did. So it opens a new tab, interviews 3. It contains only 79 entries, 79 observations, 79 rows, and 5 columns. We have to create this intermediate object or intermediate variable to temporarily host the information, and then we use the result to do the next function select. We can also nest functions. Let's say select and then filter. So that's the result we get. We get the same result, 39 rows and 5 columns. But in a different way, we kind of nested the function. This way, it's easy to understand, but we have to create this intermediate object. This way, it's kind of just one command line. It's a long command line, but it hosts everything. If we have more steps, it will become difficult. So these are 2 ways to kind of handle multiple step subsetting. There is a 3rd way. We use an operator. We call that pipe. This is also called pipe. This pipe looks like percentage greater than and so how it works is like we put interviews and then followed with pipe. We can use the shortcut is Control Shift M. Control Shift M. And then we do the filter. This time, we don't need to put the data frame here. We just have the conditions here. And then
More
I'm having some trouble. Can I see the script again?
Okay. Which, this one?
No, it was that I was just following your interviews review. Yes, two.
Because you interview three, you do. I'm looking for three.
But she also did interview.
Interview two, here.
But we didn't ever see that in a new tab, is what he's wanting to do. We never stopped to take it and look over there. We just interviewed. We just viewed interview three. We
Yes.
never viewed interview two.
No,
Okay. Keep going, Gigi, that's okay.
I just need to write.
Oh, he just wants to see that then. Yeah, go back where it was, Gigi. Right there.
so this way we create intermediate step. We'll create this interviews two. We want to use the interviews two as the input of the function select. This is kind of the two step. We use two command lines. And this one, we nest functions. We nest the function select and interview. So it's in one command line, but we have to read it from inside out. So the first, we filtered interview using the condition village equals to this Sage village. And then we select the result. We select the 5 columns from the result. And now we are talking about the third way, that's called pipes. So the pipes, it allows us to take the output from the left, from the to the right. Let's say take the output of a function, send it to the next function, or take the data frame to the function. It will be very useful if you need to do multiple things to the same data frame. This operator required pipe. The shortcut is Control-Shift-M. And there is a way you can see all the shortcuts. That's Alt-Shift-K. Alt-Shift-K. So it will list all the shortcuts in RStudio. You can click elsewhere to hide it.
Sorry, I have a question. Is the parentheses? Oh my gosh, I forgot the name of that. Percentage, greater than percentage. Is that called pipe?
Yeah, that's called pipe.
Pipe.
Yeah. Pipe. The same as that one, same as all. Yeah, the same as this one. We call this operator or this symbol, we call that pipe. And in
Also
R, we
called
call this
Pipe.
pipe.
Okay. Thank you.
So as it's already take this data frame from left to its right, so even the filter, its first argument is data frame, we don't need to put it here. And this pipe brings the result of this filter to the next function select. So we don't need to put the data frame here too. people like to read types then, then. So for this example, we can say we take the data frame interviews, then we filter rows with village equals to this village village. Then we select columns from village through respondent form type. Already 3:53. You can just stop here for today. If I have. Okay. So. Okay. What about it? Yes. Kind of we covered today. We talk about the factor. We use factor to manage or to handle the categorical data. And there are two differences between factor and a regular vector. A factor, it behaves like a categorical vector, but it is stored in R as integers. And the second difference is it has only limited levels. It has only limited values as its levels. It's predefined. And we can create factors using the function factor. And also we can use the function levels to inspect a factor to see how many levels or to see all the levels it has. And also we can use the function levels to add new levels. And we can use the function levels to rename a level. And dates, a good practice is to store dates by its components, by year, by month, and by date. And also, sometimes when we read data into R, the date is treated as characters instead of the date format. So we can use some functions to convert character vectors into dates. The function we talk about is sDate. And sDate, we need to specify the format. And also we have a group of functions is MBY and EMY and YM, all lowercase. You can use these three functions to convert character vectors into dates. Oh, and the package we use is LubraDate.
That's right.
Also, we talk about data wrangling, and we talk about the function select and filter, and also we talk the pipe operator. Pipe operator sends the data frame to functions and sends the result of a function to the next function. And next time we will talk about other functions in Lyra. Do you have any questions?
And we're gonna show you how to get to the valuation.
Oh, yeah.
I dropped it in the Zoom link, but Jingjing will show us how to get through it on the guide as well.
Okay. So the evaluation is here on the LibGuide, R for beginners, and the second link, R. We appreciate it. If you have any suggestions, please leave the evaluation.
And do they have that link too? To get to this, are y'all comfortable getting here in class? Okay, face to face, I mean, all right, great.
Have any questions? Always.
Stop the recording, okay?